Hello and welcome back to Swizzle's zkLogin tutorial series. This is lesson 3 where we will install the zkLogin TypeScript SDK. We will look at the other SWE or Mistin Labs packages that are already installed, and then we're going to test the OAuth2 flow for authenticating our app just to make sure it works before we start putting in the crypto stuff. All right, let's dive into our implementation of zkLogin on our app. If you didn't see the first video of the series, then we made a clone of Ethos Wallet's Ethos Example app, which is a React app that has a login. You can log in with a SWE wallet. I opened a code space. I also showed you how to do that, and I showed you how to modify a button here. Now we can get started. So we're in the root directory of our app here, Ethos Example app clone 1, which I creatively named it. We'll go to our docs and follow the directions. So first we'll install the zkLogin TypeScript SDK. So we'll do npm install @mistin zkLogin. Go in there, npm, I want to allow that. Allow cut and paste if you're cutting and pasting. And you can use whatever IDE or development environment that you like. I'm just using code spaces because I like it. Okay, it looks like it did it correctly. Now we can look in our package.json file, which comes up to me in this 2-column view. If I click over here and I do package.json, it shows it correctly or in a way that I'm more comfortable with. And yeah, here we have Mistin zkLogin. Perfect. One thing I like about the Ethos Example app is it already comes with Mistin's BCS, or binary canonical serialization, which implements BCS in JavaScript, making BCS available in both browser and Node.js environments. BCS is developed from DM. Remember Libra DM at Facebook? Well, SWE and Aptos are a couple blockchains that came out of that project. It defines how a struct in the Rust language can be serialized into bytes, and it supports features that are unavailable in Golang. So it's a way of serializing data. Also, we have the Mistin SWE.js package already installed. Now that we've installed the zkLogin TypeScript SDK, we're going to configure our developer account with an OpenID provider. SWE currently supports Google, Facebook, and Twitch. More OpenID compatible providers will be enabled in the future, as I showed in the previous lesson, like OAuth2. I'm really excited about that one being enabled. In DevNet and TestNet, a dev use only client ID is provided below. These URLs can be used with the redirect URI set to https zkLogin-dev-redirect.vercel.app/API/auth, which will use a state parameter to issue a redirect to your application. So they provide these client IDs for DevNet and TestNet, which is all we have available. Actually, I think we only have DevNet right now as of September 18th, 2023. zkLogin has not been released on mainnet just yet. The following TypeScript code can be used in DevNet and TestNet to construct a login URL for testing. You could construct this URL without using any TypeScript code. You could just take this information and construct the URL. If we want to check to make sure that this works, sort of do a little unit test here, so to speak, with the URL, we can. So let's do that. I think it'd be really interesting just to show you that we can actually make this work right now. And we'll show you what it returns on the client side after we log in. So our login URL is going to be accounts.google.com/o/OAuth2/v2/auth and then a question mark, and then the params. What are the params? Well, params is a URL search params, and in parentheses, first we have the state, which is a param with redirect URI being the one param they have there for the state, and that will be your own site. Like maybe I could do swizzle.com, https://swizzle.com. And we also have a client ID, redirect URI, respond type, and scope. Now, I took the liberty of already constructing this URL and go to the beginning. So it's accounts.google.com and all this stuff, auth, and then there's that question mark. And then see, I put client ID, and then I put this client ID. See, it's the same one that they give us here for testing purposes. Redirect URI, which is the redirect URI they gave us. Then we have our response type, which is an ID token. We have the scope, which is OpenID. Nonce, I used the number 45 because, you know, I love Sesame Street and simple numbers and stuff like that. And state redirect underscore URI. So I did state equals redirect URI equals https://swizzle.com. I'm not sure that that's the best way to do that notation. I think if there's more than one term in the state, you'd have to do something else, or put some brackets in there or something like that. It's supposed to redirect to swizzle.com after we log in with Google. So let's see if it works. Let's see if it gives us a login URL, if we can log into Google, and if it redirects us to swizzle.com. Boom. I already tried this once. It had me log in. It pulled up the login screen. But here, it just did it. So you see that it worked. If you try it yourself, you're going to have to log in with your Google account, and then it will redirect you as long as you did it correctly. You got to be careful about the underscores. I spelled things wrong just slightly a bunch of times before I got it right because I was doing it manually. Okay, so here we have state equals redirect URI, swizzle.com, ID token equals EY blah 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 blah. It's a really long token here. Wow, that's a long token there. Oh my gosh. Is that all one token? Look at that thing. It's huge. That's longer than my street address, I'll tell you that. My goodness. Are they serious right now? Okay, how long is this token? There it is. And auth user equals 0 and prompt equals none. So there you go. Now that token is our JWT. Once the OAuth flow completes, the JWT token can be found in the redirect URL. Now that we've tested our login URL, we can go back to our high-level flow and see what we're going to do to actually implement this. So remember I put in the number 45 as a nonce? Well, we need a nonce that corresponds to the ephemeral public key from the key pair created by the wallet. That's what we're going to do next. Let's look up the nonce. We generate the nonce and then generate randomness from this Mistin zkLogin package. Const nonce equals generate nonce with the ephemeral key pair dot public key, comma max epoch, comma randomness. So we're going to put all this stuff first in the code before we do the redirect URI stuff. This stuff where we construct the URL to log in is going to go after the stuff where we generate our nonce. Now that we've installed the zkLogin TypeScript SDK and tested our Google authentication flow, we can put that code that we just looked at together in our app. So let's do that in the next video.